So hello, welcome everyone. This is our third seminar related to our New Homes in New Ways exhibition. I'm John Bonning, I'm your host for today, but I will shortly be introducing you to Andrew Way from SCI, the Steel Construction Institute, and he will be talking about light steel framing for new homes and offer an introduction to the newly published National Light Gauge Steelwork Specification. I'd like to thank the British Constructional Steelwork Association for being a sponsor of New Homes in New Ways. For those that are not aware, currently we have an exhibition here at the Building Centre, 26 Store Street, looking at the temporary housing crisis and also a new ecosystem for delivering social housing. It's been put together with the Housing Festival, and it draws on the Housing Festival's work and their recently published publication, the MMC Playbook. But back to today's webinar. We're delighted to have Andrew Way, as I've just mentioned. Andrew is an Associate Director of the Steel Construction Institute. His knowledge in this sector is second to none. He's worked in the industry for more than 25 years. I hope you don't mind me saying that, Andrew. He's a structural engineer by background, and he specialises in the design of cold-formed steel systems and light steel framing. He oversees the Light Steel Forum Technical Membership Group for SCI, which include leading manufacturers and suppliers of light steel framing systems within the UK. Additionally, he is a member of the Light Steel Frame Association Steering Committee and the lead author of the National Light Gauge Steelwork Specification, which he'll be talking about today. After Andrew's presentation, there will be an opportunity for a Q&A session for about 5 to 10 minutes. So please do post your questions in the chat facility, the Q&A on the webinar. Andrew's already here on camera, so without further ado, I will hand over to Andrew. Thank you very much.
Thank you very much, John. Yes, thank you for the introduction. I'll just share my screen. There we go. So there we go. Yes, so yeah, thanks a lot for that, John. As you can see on the screen there, and mentioned by John, I'm going to be giving you an introduction to light steel framing and the NLSS, or National Light Gauge Steelwork Specification. So yeah, I know that probably on the webinar we've got a variety of people from a variety of backgrounds. Some of you may know about light steel framing, many of you may not, so I will give an introduction to what light steel framing is as well. Most of you won't know about or the detail of the NLSS, or National Light Gauge Steelwork Specification, because it's a publication or a specification document that was only published earlier this month. So even those who are familiar with the light steel framing sector won't have had a lot of involvement with that. They may have already purchased a copy, I suppose, but yeah, I'll go into that in a little bit. So yeah, we've heard from John about my background, so I don't need to repeat that information. So moving sort of straight on really to what is light steel framing. Well, it's a construction technology, I suppose, that's been with us for a good few years now. It's sort of back in the early 1990s that SCI, Steel Construction Institute, was involved with producing design guidance and researching this design technology. It's sort of used throughout the world, particularly countries like America and Australia. It's particularly popular, but obviously throughout the world it is popular as well now. And on the slide you can see a variety of sort of building types at various stages of construction, just to give you some idea about what can be done and is done using light steel framing, so it can be used to construct sort of traditional looking housing, so sort of 1, 2, 3-story housing with brick cladding, so you wouldn't know that it's any different from a traditional built housing once it's all finished. But it can also be used to construct sort of multi-storey, multi-occupancy dwellings of various sorts. So whether they're apartment blocks or hotels or accommodation for key workers, as in the case of some of those images on the screen, then that can be done using light steel framing as well. And it can go quite high, so up to 15 stories is possible with light steel framing. Typically it doesn't often go that high, but it can do as a structural solution. So when we're talking about multi-story, it might be more commonly used sort of 6, 7, 8 stories, but as I say, it can go much higher, and there are examples of that. So there's a few examples, as I said, with various finishes as well, and a couple of images there with light steel framing during construction. So that's the light silvery coloured sections, and I've got lots more images to show you throughout the presentation. So one aspect of the presentation will also be talking about light steel framing. The other aspect of the presentation will be talking about the National Light Gauge Steelwork Specification. So this is a joint SCI and BCSA publication. So those of you who are not necessarily familiar with the steelwork sector, so SCI is the Steel Construction Institute, more of a technical institute, providing information and guidance and research into steel in different forms of construction. And then you've got the BCSA, the British Constructional Steelwork Association, perhaps more involved with the construction side and the execution side of things. We're both membership organisations serving different purposes within the steelwork sector. So the light gauge or the National Light Gauge Steelwork Specification is a bit of a mouthful to say, so abbreviated to the NLSS, which isn't necessarily that much easier to say, but a little bit easier. So it's really a specification document with the objective of really trying to give greater consistency in specifications that are used in the steelwork or the light gauge steelwork sector. So you can see that there's a list of aspects that are covered within the specification, and I'll go into those later on in the presentation. But the intention is that it's incorporated into contractual documents used when light steel framing is used, covering all the aspects from design, manufacture, assembly and installation. So covering all the good stuff such as the materials used, the aspects of tolerances, quality control, transfer of information, really, so that everyone involved in the process knows what should be provided, what is expected of each party, and that sort of thing. So moving back to light steel framing, I'll start with that because that will obviously give us a good context for what the NLSS deals with. So light steel framing it's construction method, construction technology used from cold formed steel sections. So we'll have a look at exactly what that means as well in a couple of slides time. But it's steel sections. You can see from the images there, the relatively slender, relatively small sections, closely spaced. So if you are familiar with timber frame construction, it's not dissimilar to that in that you have vertical studs at sort of maybe 400 or 600 millimeter centers, and you can have light steel joists at similar sort of centers as well. Alternatively, you can use composite floors supported on light steel walls. So that would be a thin metal deck. So that's the second image there. So a profile deck and then in situ concrete is installed on top of that deck to perform a composite floor slab, but they are still supported by light steel walls. So light steel framing is a mixture of walls, floors and roof structures, some of which may be light steel framing, some of which may use other forms of construction methods. So with a light steel frame structure, you could potentially have timber roof trusses to form a pitched roof on top of that. You may choose not to and have a light steel frame roof structure to give you more options with habitable roof space and that sort of thing. But it's quite a flexible and adaptable method of construction, giving you lots of design variation. And that sort of leads on to some of the other benefits, really. I'm not going to sort of give you the hard sell on the benefits of light steel framing. I've just really got this one slide about the benefits, and then I'll be explaining what it is and about the NLSS in the rest of the presentation. But one of the main benefits is the speed of construction. So it can be up to 50% faster than traditional methods of construction. There's a fair degree of off-site construction associated with light steel framing, and the degree of off-site manufacture that's incorporated is obviously variable, and I'll come on to that as well in a few slides time. So that is one of the options that you can decide to sort of go fully off-site and get as much of the finishes and everything onto the panels before they're brought to site, or you can just bring a bare steel frame to site and then construct it that way. Another aspect of the benefits associated with light steel framing is in terms of its performance. So it's constructed from a steel frame, obviously. That steel frame is highly engineered. It's designed specifically for the section sizes and the material thicknesses that are used. So a lot of structural capacity can be incorporated into the frame. But of course, we've got other aspects to consider, such as fire resistance, acoustic insulation, and thermal insulation. And of course, that can all be catered for with a light steel frame. Various board finishes applied to the frame and levels of insulation incorporated within the frame or on the outside of the frame to satisfy, and if necessary, if desired, to exceed the regulatory requirements for those aspects of performance. It's a highly controlled method of construction. So as I've mentioned, a lot of the assembly and the manufacture is carried out off-site, or can be carried out off-site in those factory controlled conditions. The machinery that's used to produce the sections can produce the sections and everything to very high tolerances. That's one of the aspects of the National Light Gauge Steelwork Specification, is to specify tolerances, and when we get onto that, you'll see that they're quite tight tolerances. So we have a very predictable frame once it's constructed in terms of those dimensions, and then it's very stable. In terms of those dimensions will be sort of more or less unchanging over time, so there's no sort of shrinkage or drying out or twisting or anything like that due to different moisture levels, or thermal movement is very minimal as well. It's obviously a lightweight form of construction, so you get the obvious benefits such as reduction in demands on foundations, and it's even lighter than a timber frame equivalent construction as well. So it is a very lightweight form of construction. Obviously, it depends on exactly what floor systems you're using. If you're using the composite slab floors, which I was talking about earlier, as opposed to light steel joisted floors, then those composite slabs are going to be heavier than a joisted floor. But they do have other benefits as well. With the level of off-site construction, then obviously there's reduced deliveries to site. So the standard sort of benefits that you get with off-site manufacture, depending on what level of off-site finish that's being incorporated into the system. And then you've got good things like recyclability and recycled content of the steel and the other materials. So obviously steel is highly recyclable, can be melted down and reused as many times as you like. There's no limit on the number of times that you can do that with steel, provided it's recovered. And then I mentioned earlier about the design versatility. Because of the structural capabilities of steel, you can form not just the panels that we were looking at earlier, but you can form light steel trusses and give much larger spanning capability. And you can also incorporate hot rolled, so heavier steel sections into your light steel frame structure if you do need to create sort of open plan, maybe at ground floor level. Often you might have a sort of a podium structure from a hot rolled steel frame, maybe to create some retail space sort of at the ground floor, and then you've got residential apartments or something for the sort of 3, 4, 5 stories above, whatever that may be. So quite a lot of versatility in the structural solutions that can be applied. So moving on to just have a look at in detail about what we're talking about when we're talking about the steel frame sections. So you can see we've got vertical steel studs, and these are typically what we refer to as lipped C sections. So sort of 2 examples of a lipped C section shown on the slide there. And the material thickness is really quite thin, so it's sort of 1.2, maybe up to 3 millimeters thick, depending on the loading applied, the number of stories that it's supporting. So these are typical values. You may find cases where you've got thinner or thicker material, but these are sort of the typical ranges. And then the depth of the section, so the sort of the depth of the wall, if you've got a single stud wall, so it could be sort of 90 millimeters up to 150 millimeter deep would be typical. Something around 100 is the most common. And then on the outside of that, you've got sort of layers of plasterboard applied to satisfy acoustic and fire requirements. So that's sort of a typical sort of wall build-up. In terms of floors, you might have a much deeper light steel joist, so maybe 200 to 300 millimeter deep joist, and then that would have obviously a ceiling below and floor finishes above. And then if you're dealing with a composite slab, so you may have a composite profile deck that maybe have a profile of maybe up to sort of 80 millimeters deep, something like that, and then sort of 150 mil total depth of the slab, again with a ceiling below and potentially some floor finishes above. But of course, with that composite slab, you don't need as much mass incorporated into those finishes to satisfy the acoustic requirements that you would do with a light steel joisted floor. So you can see in the diagrams there, or the photographs there, the lower photograph is showing the underside of a composite slab with that profile deck supported on light steel floors, and the upper one has got the light steel joisted floors, or light steel joists supporting the floor above. Of course, we're dealing with structural system here, so the light steel framing needs to provide lateral stability. Sorry, I am a structural engineer, so I do like to talk about the structural aspects of the system. So we do need sort of diagonal bracing, and that comes in a variety of forms. So as I mentioned, we could be up to sort of 15 stories with light steel framing, so we need quite a lot of lateral stability to resist those wind loads, and that's typically provided by diagonal bracing, as I've said. This may be X bracing, which may be cross flats of steel attached to the steel panels in the walls. Various aspects that you might need to consider. I won't dwell on those. Or you can incorporate sort of these truss systems within the wall panels, so sort of various options. So you can have vertical lattice trusses as shown in the top photographs, or you can have what's referred to as K bracing in the bottom photograph. So as well as showing the actual bracing system, I just wanted to make sure that I was showing you images of what light steel framing looks like when it's during construction, because when it's completed and all the cladding's on, you never get to see what the structure is, and you can't see what the actual structural solution is. So you may have seen lots of light steel structures without ever realizing it, really. So talking about the process, really, and I'll take you through the process of construction, and the same sort of process is followed in the NLSS, which I'll talk about later on in the presentation. But starting with the design and detailing. So one of the benefits and the aspects of light steel framing is that it is sort of highly computerized, both at the design and the manufacture stages. So we've got some images of 3D models that are created. So it's the typical case that a 3D model of the structure would be created. So that's showing the light steel structure, as in the case of the sort of the bottom left image, with lots of sections of grey coloured material in a sort of skeletal form, whereas the top left image is more of a rendered image. So it's got the light steel framing underneath, but it's also got the cladding and the wall build-ups applied as well. So you can see the complete structure. With all of that allows the detailing, particularly at junctions, to be worked out. So where you've got board layers, whether they be on the floor or the walls, and different frames coming into contact, you need to work out, obviously, how that detail is exactly going to work and how it's going to be constructed. So that can all be done with the 3D models as well. And then the image on the bottom right is really about the structural solution. So different wall panels indicated on that drawing. So that's a plan view of a typical floor level. So you've got the direction of the slabs shown with the arrows, so which way they're spanning. They could be slabs or they could be floor joists, as I've mentioned. And then you've got slightly different coloured wall panels. So whether that indicates whether they're load bearing or not, or the different gauge or spacing of the wall studs can all be color coded during the design and detailing process. And then once that's all worked out, we get onto the actual manufacturing process. So the image on the I'll just get my pointer on the left here. So it starts off with these coils of flat steel. So this might be whatever it is, the 1.5 or the 2 millimeter thick steel in a nice coil, and then that's fed into a rolling machine, which may be of various forms, but a rolling machine of one form or another. And through these various rollers, that flat steel is transformed into a lipped C section, or whatever the final desired section is. And that's obviously where some of the tolerances and everything come into play to make sure that machine can produce what you want. On that flat steel, I should say that the steel is pre-coated at this stage when it is in the coil form, with a galvanizing coating, protective coating for corrosion protection, or some other form of zinc coating or other protective coating. So it may include magnesium, it may include somehow aluminium components as well, but some form of corrosion protection of various thicknesses. So that's one of the quality control procedures, to make sure you've got the right steel grade and the right coating at this process. And then once the sections have been formed, cut into desired lengths, then they can be transformed, assembled into panels. So here we've got a typical sort of wall panel being assembled. So you've got a top and bottom head track with studs in between. And you can see in this case they're being joined together with self-piercing rivets. It could be that they're bolted together or screwed together. And once those panels have been manufactured, then they're delivered to site. They may be delivered to site as sort of bare steel panels, as in the case of this photograph here. You can see there is some color coding being applied to the different panels. It may indicate different locations on the floor, on the footprint of the building of where they're required, which may correspond to, as I said before, different steel thicknesses being used in the studs, for example. That's all part of the construction process to make sure we obviously get the right panels in the right place. Then the installation. So again, in this case, we're dealing with bare steel panels. So the top left, you've got a light steel wall panel being lifted into position. Then the top right is a floor cassette. So floors may be installed as cassettes with boards pre-attached to the top surface. Obviously speeds up the construction process even further. And the construction would obviously work by going up story by story, and at different intervals. It may be beneficial to position materials that are used for the finishing of those wall panels within the space at that stage before the next floor level goes on. Obviously, it's much easier to put those materials in position before you've got that floor in place. So that's quite advantageous. Or these may actually be sort of things like bathroom pods, pre-manufactured modules that you might have in sort of typical student accommodation or hotels. So that again speeds up the construction process, that labour-intensive process of fitting out a bathroom or whatever, and finishing it can be installed and positioned at that stage. And then that final image on the bottom right there sort of shows what the light steel frame looks like during construction. As I said, you work up story by story, and you typically have you typically have scaffolding going up in unison on the outside of the structure as well. Obviously, it depends on how many stories we're talking about. So all of those images sort of showed bare steel panels. It's also possible to have some level of pre-finish applied to the panel. So I mentioned this earlier on. So in this image on the left-hand side, we've basically got an external sheathing board applied to the panel. So you can see them lying on the ground here on battens waiting to be installed, but they're already pre-boarded with that external sheathing board. Whereas the other extreme on the right hand side, we've got a panel here waiting to be installed, which has already got external cladding applied, windows and doors already installed within those panels. And again, that can be installed to the construction, and obviously speeds up the construction process on site quite considerably. And you can see some of those panels or similar panels installed on this building here. Panels have also got some sort of pre-finish brick slip cladding system applied to them as well. And then all that you need to do on site is obviously apply the finishing, the cladding for the joints between those pre-installed panels. I mentioned earlier about fire, thermal, acoustic performance. So just to give you some details, really, obviously I can't really go into it in a huge amount of detail, but those aspects of performance are provided for by the board finishes. So gypsum based boards applied to the ceilings and the walls to provide that fire resistance, insulation within the walls and the floors, cavity barriers around the junctions to provide all that thermal and fire resistance that is required as well. So SCI and individual light steel frame manufacturers will have lots of guidance and details about how they satisfy those requirements. And that sort of leads us on really to independent verification and certification systems that are available. So as I've mentioned, SCI have been involved in providing guidance and information on light steel framing systems for sort of over 30 years now. And over the vast majority of that time, we've worked with warranty providers, obviously NHBC, but also other warranty providers. And we provide a particular system certification for light steel frame systems, so called Stage 1 system certification, to make sure that this light steel frame is designed structurally in accordance with the necessary codes and standards, and it's got that required stability and durability aspects catered for with the detailing. So I think currently we've got well over 25, maybe up to 30 systems that have got that Stage 1 certification for light steel framing. There are also other certification systems available. So we've also got a UCAS accredited certification system, which goes into all aspects of manufacture of these light steel frame systems, whether it be panelized or complete volumetric modular systems. So the fire, the acoustics, as I mentioned, would be covered by that, and also the factory production control. SCI don't get involved with CE or UKCA marking, which is necessary for construction products. So that's something that BCSA and their sister company can assist with. So the actual forming of the sections and the fabrication of the sections, which is something else that should be looked for when specifying a light steel framing system. And again, that leads us on to the next slide, really, which is all about execution standards and the story to how we got to the National Light Gauge Steelwork Specification. So for a long time, well, the first edition, as you can see, of the National Structural Steelwork Specification, so the NLSS, was published back in 1989, and so that's the document, or the specification document, for hot rolled or heavy gauge structural steel framing, whereas the National Light Gauge is for this thin cold formed steel sections and the light steel framing side of things. So it's the equivalent to that, but until this year there hasn't really been the equivalent for the light gauge side of things, but it's been long accepted that the NLSS has been a crucial part of the success of the hot rolled steel frame industry, and so it was certainly required or needed to have an equivalent document for the light gauge sector to continue to grow and get that uniformity in terms of specification. In the intervening period, there has been various guidance documents and best practice guidance and some execution standards from BSI based on European standards, so EN 1090. So that is the same standard that is used for hot rolled steel framing, and there's a specific part for cold form steel. So it's all following the same sort of process as hot rolled steel framing, but there are obviously some specific aspects to light gauge steel that are different to hot rolled or the heavy steel framing. So just looking at what's included within the NLSS, Well, it's quite a substantial document, really. There's 80 pages of information within there, covering the various aspects, and you can see that there's a substantial part of the document related to workmanship. So this is not really a design document at all. The structural design would all be covered by Eurocode design and other SCI guidance documents. This is particularly about workmanship, transfer of information, and the various parties working together, and everyone understanding what is required. A few points of clarification about the scope of the NLSS. So it's can be used for structures or buildings that are designed either in accordance with the Eurocode design standard, so that's Eurocode 3, EN 1993, or can also be used for buildings that are designed to the previous British standard, so 5950, and the specific parts associated with cold form steel sections. But the execution of the construction and manufacture should be in accordance with EN 1090, as I mentioned. And it's all about load-bearing structures. So light steel sections and cold form sections are used in various different aspects of construction, often used as secondary steel work or non-load bearing parts of the structure related to cladding and infill walling and that sort of thing. But the NLSS is particularly directed towards load-bearing light gauge steel framing and the associated components, so including the bracing aspects, which I briefly touched on earlier on. So what isn't included and is listed there. So it's important to recognise that not all aspects of cold form steel products are covered by this NLSS. Maybe future editions may broaden the scope and start to bring some of those on board, but for this first edition, it's quite focused on what you can see on the slide there. And the NLSS is really there to provide this framework for the design, manufacture, and installation of light steel frame systems, carrying out, or not carrying out, but ensuring that all aspects of that process are carried out sort of with transparency and with communication between the various parties to make sure that those different parties, so we can see them sort of listed there, that second or sub bullet point, designers, manufacturers and installers are all aware of their roles, responsibilities and influence on the project. So in some cases, the design, the manufacture and the installation of the light steel frame could all be carried out by the same company. In many cases, those aspects will be split between different companies or different. So the manufacturers may also be the designers, but not necessarily the installers. The installers may be subcontracted by the manufacturers. So there's all different possibilities of how the contract may be split, which is another reason why the NLSS is required, and those responsibilities and roles are detailed in that that document. But as I mentioned earlier, a large part of the document is associated with workmanship. Some of that is related to sort of identification, traceability, control of the actual materials to make sure we're getting what has been specified. So that includes the sections, but also how those sections are fastened together, because again, there can be quite a variety of different fasteners involved in a light steel section or a light steel frame solution. As I've mentioned, bolts, screws, rivets, and some other specialist fasteners can be incorporated. But now I want to move on to some of the aspects of accuracy. So that's accuracy of manufacture. So that's what occurs in the factory, but also installation as it occurs on site. So we have got accuracy of the individual components, and there's sort of two types of tolerances. So we've got what's called essential tolerances, which are needed for the system to behave as intended at design. So that's sort of a safety critical, if you like. And then we've got functional tolerances, which are more about fit up and ability to install and build the frame. If we don't meet these tolerances, then those aspects could be inhibited. And these are just a selection of the tolerances that come from the NLSS. There's many more listed in that document. So that the E there just stands for essential. And then there's also tolerances associated with assemblies of components. Excuse me. But the same sort of principles apply. And then you've got aspects of tolerances to do with the installation on site. So that relates to not only the light steel frame itself, but what it's being constructed off of. So that the tolerances that are required for the ground floor slab, for example, if we get that right, then the structure above will follow, because that is produced to very high tolerances. And again, we've got some different images of panels being installed. So to finish up with, really, I just want to point out that the various sources of further information, not least the National Light Gauge Steelwork Specification itself. So that can be obtained from the BCSA. So if you go to the BCSA website, that will be relatively easy to find from there. Also, SCI have got a lot of information about aspects of steel framing of all sorts, so please visit our website. And if it's more sort of things like case studies that you're interested in, then the light steel frame manufacturers will have lots of case studies on their websites, and I've just got a few photographs on that slide of recent case studies. And hopefully that's given you a good introduction to light steel framing and a bit of an introduction to the NLSS as well. So yeah, thank you very much. I think perhaps now over to John, and maybe we've got some questions hopefully from some of you.
Yeah, thanks, Andrew. Really interesting. Yeah, so just to remind everyone, please do post your questions in the chat, in the Q&A section. And while you're sending those questions in, I'll just remind you that actually this event has been recorded, and you can find it on the Building Centre YouTube channel. It'll be live from probably next week, early next week. And indeed, you'll find all the talks and events from New Homes and New Ways on the Building Centre YouTube. Really fascinating. For me, particularly seeing the images of the manufacturing process. So thanks for sharing that, Andrew. It's greatly appreciated.
Yeah,
I'm going to kick off the questions, Andrew, if that's all right.
of course. Yeah.
What percentage of buildings in the UK are constructed from a light steel? Do you have those numbers?
I don't have exact numbers. I think it is. We're mainly talking about residential type buildings in most cases, because it lends itself to relatively short spans in a lot of cases. You can obviously incorporate hot rolled steel sections to get longer spans, but if you need lots of longer spans, then probably light steel framing isn't the right way to go. But yeah, in terms of residential, I don't know. It is sort of single digits percentage wise.
Right.
So I don't know, 5% or something like that. I don't know. And it'd be a higher percentage when you start talking about multi-storey, multi-residency apartments and that sort of thing, city
Yes.
centre developments.
Yes.
If you're talking 2-storey houses, then there is some built, but yeah, it's in the minority certainly.
Yeah,
But
okay.
but yeah, there's no reason why it shouldn't be.
No.
But yeah,
We hope it increases.
yeah.
There's more of them. Just picking up the question here from Thomas, and Thomas is asking, which party would calculate the suitability of any external layers covering the steel frame walls from the outside, like cement board, wood fibre insulation, and finishing layers?
Okay. Yeah, it's a good question. It's a good question. I think it depends what you're asking that board to do. You know, do you want it to be involved in the structural solution? Because I didn't really mention it in my slides there, but it can be part of the stability system in some cases, in which case it would be the designer, which would probably be the light steel frame manufacturer in a lot of cases, would carry out that design, and they would have their system design solution to incorporate structural aspects of that sheathing board. If it's really there just as a sheathing board for the sort of thermal performance, if you like, then that again, it might be the light steel frame manufacturer, because we've got to think about on the outside of that sheathing board, there'll be some insulation applied. So typically a stone wall based insulation for fire purposes. But there's an awful lot of boards out there, sheathing boards, and they can all be used, you know, for practically all of those solutions. So, but it has to be incorporated and taken account of. So, a good place to start is really the light steel frame manufacturer. I would suggest, but again, whoever is really designing the thermal solution, I think, and the fire solution, which again might be the light steel frame manufacturer, but might not be. So yeah, it's a tricky one. It's not the same for every case, which is really again highlights the need for the NLSS to clarify who's doing what. Yeah.
Okay. And then we've got a couple of technical questions coming in about when would you use the reduced minimum tie force for 15 kN? Must everything in the module be light gauge or is based on weight of the module? What is the criteria for using reduced tie forces?
Yeah. Again, good question. So in most cases, it's the majority. If the majority of the structure or the region that you're designing with that reduced tie force or designing your tie force, then if it's light steel framing, then obviously you use that reduced tie force of 15 kilonewtons. If you're tying in a hot rolled beam, then I would argue that it should be the standard 75 kilonewtons that you're tying in, which I appreciate it can be difficult to do if you're tying that to a light steel column or group of sections to act as a column. So yeah, it comes down to the individual location, but I would personally say that if you're tying in a hot rolled section, you're dealing with the hot rolled requirements, which is 75 kilonewtons.
Okay, and that links into another question that's saying if you use the minimum tie force of 75, what is the most efficient way to connect this into diaphragm with timber and light gauge members?
Yeah, so you're probably looking at some form of steel plate with a bolted connection to the section, the hot rolled steel section, and then either well, probably bolted into the light gauge steel panel as well. Yeah, it may be possible to do it with some screw fixings, but that's going to take quite a few to get to that 75 kilonewtons.
Okay, thanks. Question here from Thomas Dine, an architect, saying, do I need to refer to the NLSS or can I rely on the frame supplier to provide all necessary advice?
Yeah, well, the NLSS is not a design document. You know, it's a sort of intended to be a contractual specification document. So if you're talking about tolerances, say for the steelwork, then you can refer to the NLSS. But that document won't tell you how to tie things in or what thickness of insulation to provide for different U values or different fire resistance periods. You know, that would come from, in case of fire resistance, it would come from fire testing, and yeah, that could come from the frame manufacturer. It could come from board manufacturers. Yeah.
And actually, Thomas follows that up with, are frame manufacturers' suppliers accredited by an independent body?
Not necessarily. I mean, lots of them will have their own, you know, will have gone out to get certification of various sorts from people. So, you know, there's all sorts. I mentioned a few that SCI are involved in, but obviously, you know, NHBC accepts is available. There's a BOPAS scheme. You know, there's other, you know, there's other UCAS accredited bodies that will maybe not certify schemes, or not schemes, systems, because I think SCI is one of the few companies that has got the UCAS accreditation for systems. But yeah, individual products maybe. But yeah, it's when different products are brought together that often you get the difficulties about, okay, well, that's not covered by our certification because we do the product, not the system, and so yeah, if you can look for systems that have been certified rather than individual products.
Super. Okay. Another question here. How many projects have you taken through a Gateway 2 application? And what are your experiences of this?
Well, fortunately for me, I haven't done any because I don't really get involved in real projects. I just offer design guidance really, or SCI as a company offers design guidance to companies that are doing real buildings. So yeah, as a company, we haven't been involved in any of that. So yeah,
Okay,
unfortunately, can't
we're
respond.
moving on from that one, Andrew. Uh, Mamu is asking, does the infilled material affect the buckling length of the studs, as it is non-shrinkage material, so it prevent or decrease the buckling length of the members?
Um,
Question there.
yeah. So I mean, the infill material, which is typically some form of insulation, it won't affect the buckling length of the studs at all. If you've got, which you normally will have, boards attached to at least one side of the frame, possibly two sides of the frame, then that would affect the buckling length. Whether or not you take that into account in design depends on what supporting information you've got. I know some light steel frame companies have carried out testing and all that sort of good stuff to determine what extra restraint they get from the boards. Some companies have just taken the decision that they don't want to take an account of that. They know it's there in practice, but in their theoretical calculations, it's ignored, just so they've got that extra bit of peace of mind in their structural calculations that they haven't squeezed everything out of the system to the nth degree.
Okay. And if I'm understanding this question correctly, Simon Khan is asking, is the system used for constructing whole apartment units in a factory? Or I think it's mainly, what is the system used for constructing whole apartment units in a factory for craning onto a prepared site, e.g. a roof extension?
Yeah, well, you could use light steel frame to produce a volumetric system, you know, so a module, whether that be for a roof or anywhere else in a structure, that could be entirely from a light steel frame components. It's more likely to be from a combination of heavier steel sections with light steel walls and floors, and then obviously depending on the size of the apartment, it may be two modules brought together 3 modules brought together on site to form however big the apartment is, but yeah, it can be used.
Okay, a question I thought may come up, and again, not sure if you can, or if there's even the research on this. Do you have a cost comparison with timber frame?
We don't have anything. I mean, we did have, 20 years ago, but that's obviously going to be completely out of date and things that moved on. But yeah, it's well, cost comparisons are really quite difficult to do, with all sorts of competition law and getting people to hand over cost information and everything else. So yeah, unfortunately, it's something that we'd like to do, but it's just proven impossible to actually get the information to do it
Yeah,
as an independent
yeah.
organisation.
And I guess this is one for you with your structural engineering hat on. Questions being asked here. I think during the design process, we should take in consideration the effect of vibration due to the thin thickness of the use of light steel gauge? Question mark.
Yes, certainly. So really, if we're talking about residential buildings, the only um, source of vibration that we really need to think about is footsteps of people walking around a building. So there are special rules. So you can design the light gauge steel floors to not be overly lively, if you like. So um, if you don't follow those rules, then you can get bouncy floors, and there have been 1 or 2 cases where there has been issues and particular situations where those rules haven't been followed. But if you follow the rules, which have been in existence again for, I don't know exactly, but yeah, probably 15, 20 years, then you get a good solid floor, and you don't have the issues. You may need to think about placement of washing machines. If you put that in the middle of a long span floor, then that's not a smart idea. But up against a wall, which is the typical place, then you don't have an issue as well. So yeah, you certainly need to take it into account, but there are established methods to do that,
Sure.
and
Sure.
they're not complicated methods. You don't need to do any sort of finite element analysis or anything. It's a hand calculation.
Yeah. Okay, one quick final question for you, Andrew, and thanks to everybody for all your questions, some great questions. How much research has been done on cold bridging, as many of the designs seem to have the sections across the full wall build up? For example, would you need an additional layer of insulation on the inside, perhaps?
Well, in most cases, for an external wall, you'll have insulation on the outside of the light steel frame. So you might have insulation between the studs, but you'll also have insulation on the outside. And one of the important reasons for that is to make sure that we don't get, or the steel stays on the warm side. You don't get that steel becoming cold, and any condensation doesn't form on the steelwork. Obviously, it's got a galvanizing coating, but we don't want that to get wet. And so we keep the steel on the warm side, warm frame construction, or hybrid construction as well. So therefore, we don't have any durability issues, and it takes account of that thermal bridging aspect. But yeah, we've got publications on thermal bridging and light steel framing as well, if you want a lot more information.
Okay, thanks, Andrew. Well, that just sort of leads me to thank everyone for attending the webinar, and especially to Andrew for a very interesting and insightful presentation. Just to let everyone know, we do have an upcoming webinar next week on how councils in the MMC sector can support each other. It's taking place on Thursday next week, the 5th of December, 1 to 2 p.m. And yes, folks, December has arrived, or nearly upon us anyway. And finally, just to say, we've released tickets. They're on our website for our 2-day summit on new homes and new ways, the 12th and 13th of February. So do take a look, and we hope you can join us for that. And again, Andrew, many thanks. Wish everyone well, and we hope to see you in the building centre very soon. Thank you.
Thank you. Cheers.